Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Similarity. This video will help you identify similar figures, find unknown dimensions of similar figures, and find the area of a similar figure. Identify similar figures. Let's start with some definitions. Similar objects have the same shape but may have different sizes. The corresponding angles of similar figures have equal measure, and the corresponding sides of similar figures form equivalent ratios. Because the following two triangles have identical shapes, they are similar. The larger triangle on the right is an enlargement of the smaller triangle on the left. Now, in similar figures, the corresponding angles are equal. So if I take a look here at angle A, which is the measure of this angle right up here, the measure of angle A is going to actually equal the measure of D in this triangle. So the corresponding angles here are all equal in value between the triangles. Now, the corresponding sides are not equal in value. You can see, obviously, that A, the side of A over here, is smaller than D. However, the ratio between these two triangles are going to be equivalent. So if I write the ratio of side A to side D, that is going to have to be equivalent to another set of corresponding sides, like if I take B to E. And notice A was the smaller triangle, so I would say B on the smaller triangle is to E on the larger triangle. So these corresponding sides will all form equivalent ratios, and we can use them in a proportion like this to solve for an unknown value. The one thing that we have to make sure, though, however, is that we're being consistent. Notice the way I had my ratio set up here was small triangle over the big triangle. And as long as I was consistent in each of my ratios here, I did small to big and then small to big, these ratios are going to be equivalent. I'll be able to solve for an unknown side in one of these two triangles. Now let's take a look at an example that will help you understand similar figures. Example 1. Which of the triangles A through D is similar to the triangle below, and then what are the corresponding sides? So let's see, if triangle is going to be similar above, it basically has to have the same shape this one is. Maybe it's an enlargement of it or a shrink of it, but it has to have the same shape. Let's take a look. Triangle A has a right angle in it, so it's a right triangle. Our triangle does not have any right angles, so those cannot be similar triangles. Triangle B is an equilateral triangle, which means all the sides are the same length. Our triangle that we have, that doesn't work. C, that is a match. Same shape. Our triangle is bigger than C, but it's the same shape, looks like the same angles are the same side, so those are our similar triangles. D also will not work because that has a right angle in it, so that's not going to be similar. So what we want to do is we want to state that these two triangles are similar. So I would say triangle, and let's talk about this big one that we have down here first. And I'll start by naming this triangle. I'll start with the bottom here. I'll start with E. So I'm going to start with triangle E. Now I have to name the other sides of this triangle. I'm going to go in a clockwise rotation now, so triangle E, then going clockwise. I would say F is next, E, F, still continuing clockwise, D. There are the three sides of my triangle. That will identify my triangle. So triangle EFD, and this is the symbol we use for similar, just one little squiggly line, is going to be similar to this triangle above, and now I want to match up the corresponding sides as I name this. So notice I started at the bottom, which was E, so up here I'm going to start with A. So I would say triangle A, and again now I'm going to work clockwise since I did that in my triangle down here. So going clockwise, I would next come to side B, E, B, C. So triangle EFD is similar to triangle ABC. Now let's identify the corresponding sides. So E corresponds to A, F corresponds to side B, and D corresponds to side C. Now it's time to check your understanding of similar figures. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. which of the triangles A through D is similar to the triangle below, and then what are the corresponding sides. So if we take a look at our triangles, A has a 90-degree angle, but the sides are equal in length, so that's not going to work. B is equilateral, that's not going to work. C doesn't work. It's similar to D. So we would say that triangle, and let's start now. Notice, let's start from our 90-degree angle. That's kind of a good place to identify. So here's my 90-degree angle. So I'll start with the shorter side of the 90-degree angle, which is E here. So I'll say that triangle E, and then go clockwise again. So E, F, D. Now taking a look up here, here's my right triangle. And so I'm going to start with the shorter side, which is A. This triangle A, and now I'm going to go clockwise again. So I would say B, C, B, C. So those are my similar triangles. And now I would say that E corresponds to A, F corresponds to B, and D corresponds to C. Find unknown dimensions of similar figures. When two figures are similar, the corresponding sides form equivalent ratios. The equivalent ratios may be used to write a proportion, which can be used to solve for the length of an unknown side. For example, in my first triangle here, I know all of the side lengths. And this triangle is similar to my next triangle here. But notice, in this triangle, we don't know the length of this side. Now, since these are similar triangles, we can use a proportion to solve for this unknown side. And we could use any three of the following proportions. So I could say here, it looks like I've taken on a small triangle. I would say 3 foot is to 6 foot. That's what made my first ratio here. And I would say that's the same on the small triangle. 4 feet is to x feet, my unknown. Now I could do the same thing. Here's another example of how to do that. In this case, I've switched it up a little bit. I'm starting over here with 10 feet on the big triangle. 10 feet is to 5 feet. So notice I'm going big to small. And so 10 feet is to 5 feet. And now I want to go big to small again. So I would say x feet is to 4 feet. And then the third ratio is the same thing, except here I'm saying x to 4. So I'm going big to small is the same as 6 feet is to 3 feet, big to small. As long as I'm consistent about how I set up these proportions and make sure that I'm consistent, I could solve for that unknown side using any three of these ratios. Now let's take a look at an example that will help you understand how to solve for a missing side length in two similar figures. Example 2. The following two triangles are similar. Write a proportion and solve for the length of the unknown side. So we have our similar triangles. In fact, they're even situated the same way. They even have the same orientation here. They're both facing the same way. And so let's take a look at our corresponding sides. Here are our corresponding sides. We could say 5 feet is to 8 feet. There's a set of corresponding sides. We could also say 10 feet is to y feet. And so that is going to give us our proportion that we need to solve for this unknown side. So we would say 5 feet is to 8 has to be the same. And notice I went small to big. So 5 to 8 is the same as 10 to y. Again, small triangle to big triangle. Now I have my proportion set up. Now all I have to do is solve this proportion for y. And remember, the first thing that we do, we'll come over here, is we need to get y in the numerator of this ratio on the right side. So we're going to flip both sides. So I would say 8 over 5 then is equal to y over 10. Now we're trying to get y all alone. So we want to undo this division by 10, so I'm going to multiply this side by 10 over 1. Whatever I do to the right side of this equation, I got to do the same thing to the other. So I'm going to multiply this side by 10 over 1. Let's take a look. On the right side, the common factors of 10 divide out and leave me with y over 1, which is just equal to y. Now let's look at the left side. On the left side, I have to multiply some fractions together. So I'm going to factor that out, starting with 10 here in the numerator. 10 when I factor that is 2 times 5. 8 when I factor that is 2 times 2 times 2. In the denominator I have 1 times 5. Now let's look for some common factors. Yep, I have a common factor of 5 that I can divide out. And so what I'm going to do is I'm going to multiply all of this stuff left. In the numerators going across the top here, 2 times 2 is 4, times 2 again is 8, and then 8 times 2 is 16 over 1. So I'm going to get that y is equal to 16 feet, since I was measuring in feet for that missing side. So we can come up here in our picture and say that y is 16 feet in length. Now it's time to check your understanding of solving for an unknown side in similar figures. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 2. The following two rectangles are similar. Write a proportion and solve for the length of the unknown side. Okay, so the rectangles are similar. They're set up with the same orientation. So I can go, in this case, I'm going to go big to small, just because that's the way they're set up. I could do it the other way around, but it seems easier to read left to right. So I'll go big to small, and I would say that 6 is to 2. That has to be the same as 13 is to x. So now all I have to do is solve this proportion. And so again, we need to get x up in the numerator, so I'm going to flip both of these sides. So this is going to become 2 over 6. This is going to become x over 13. Now I need to undo that multiplication of that division by 13, so I'm going to multiply by 13. So I'll multiply by 13 over 1 on this side. Do the same thing to the left side. Let's take a look now. Common factors of 13 divide out here, leaving me with x over 1, which is just equal to x. And on the left side, let's go ahead and factor this out. 13 is prime, times 2 in the top. In the denominator, I have 1, and then 6 is 2 times 3. So it looks like we have a common factor of 2 that's going to divide out. Let's come over here to finish the problem. X on the right side. On the left side, I have 13 over 3. Now, we're going to want to write this as a mixed number because we don't want to tell anybody 13 over 3 feet. That's not really something that we can get a hold of. So let's write this as a mixed number. So remember, we divide. So over on some scratch work, we'll say 3 into 13. 3 goes into 13 4 times, which is 12. So we get a remainder of 1. So as a mixed number, that's going to be 4 whole times with 1/3 left over. And that was inches. So we write 4 1/3 inches is equal to that unknown side, x. Find the area of a similar figure. We can use similarity to determine the unknown lengths of any sides needed to find the area. Once the dimensions are known, we can use the appropriate formula then to find the area of the figure. Now let's take a look at an example that will help you use similarity to find the area of an object. Example 3. The two rectangles are similar. Find the area of the green rectangle. So we're asked to find the area of this green rectangle. Well, to find the area of a rectangle, remember, this is what we need. We need length times width. Well, we have the length, but we don't have the width. So let's use similarity to figure out this width. And so, looking at our rectangles here, I'm going to go small to big as I write these ratios. So I would say, on the small side, 4 feet is to W. So I'd say 4 is to W as 8 is to 14. As 8 is to 14. We got to get W in the numerator, so we're going to flip both sides. So we're going to have W over 4. And on this side, we'll have 14 over 8. Okay, I need to get rid of that division by 4, so I'm going to multiply by 4 over 1 on both sides. Let's take a look what we have. Over here, common factors on the left, common factors of 4 divide out. We're left with W over 1, which is just W. On the right, we got some factoring to do. Across the numerators here, 14 is 2 times 7. 4 is 2 times 2. In the denominator, 8 is 2 times 2 times 2, and then times 1. Let's look for common factors there. We have a pair of 2's, another pair of 2's, and finally a third pair of 2's. So it looks like we're going to get 7 over 1, which is just 7. So the length of that unknown side, or the width of this particular rectangle, is going to be 7 feet. So up here we can say then that W is equal to 7 feet. Now we know the dimensions of this rectangle, we can calculate the area. So let's come over here to do that. So area, again, equals length times width. And we know the length is 14, and we know the width now is 7. So we're going to need to multiply 7 times 14, so we'll come over here on some scratch work. 7 times 4 is 28, carry the 2. 7 times 1 is 7, plus 2 is 9, so we get 98. So the area of this rectangle is 98, and in this case we're talking about area, so we need to make sure we're talking about square units. So we want to say 98 square feet. Now it's time to check your understanding of finding the area of a similar figure. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 3. A blueprint of a rectangular room is 3 inches by 4 inches. If the longest wall of the actual room is 12 feet long, what is the area of the actual room? There's a lot of information going on there, so we're going to need some pictures to understand what's going on. And we've drawn those pictures for you here. So in our blueprint, the picture of this room is 3 inches by 4 inches. And then the actual length of the room is 12 feet. And we need to know the width of this room in order to find the area of this room. So since these rectangles are similar, the blueprint to the actual room, we can use a proportion to solve for this unknown width in the actual room. So I'm going to set up my proportions again from the smaller blueprint to the larger actual room. So I'm going to say 3 is to W has to be the same as 4 is to 12. And now I want to get W in the numerator, so I'm going to flip both sides. So I would say W over 3 and then flip the right side, 12 over 4. Now we're trying to get W all alone. It's being divided by 3, so we're going to undo that, multiply by 3 over 1. Do the same thing to the right side. Let's take a look. On the left side, common factors of 3 divide out and leave me with W over 1, which is equal to just W. On the right side, we're multiplying fractions, so let's factor this out. 12, I'm thinking 3 times 4. So there's 3 is prime, 4 is not, so we'd factor that into 2 times 2. And then I have times 3. In the denominator, 4 is 2 times 2 times 1. Let's see, common factors of 2 are dividing out. So that looks like it's going to leave me with 9 over 1. Well, 9 over 1 is just 9, and that was feet. So now we know the width of our actual room is going to be 9 feet. Now that we know that, we can find the area. Again, to find the area of a rectangle, we take length times width. In this case, the length was 12. The width was 9. So 12 times 9. 9 times 2 is 18. Carry the 1. 9 times 1 is 9. Plus 1 is 10. So 108. And this is area. So we want to make sure we're using square units. In this case, square feet. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.